Okay, the lesson for today in 5.3 is least common multiple. And what we're going to do is we're going to do it two ways, just like we did greatest common factor. One, we're going to do it by listing the multiples, and the second way by using the prime factorization that we get from a factor tree. So a multiple is different than the factors because multiples are like, okay, if I take 9 times 1, I get 9. 9 times 2 is 18. 9 times 3, 27. 9 times 4, 36, and on and on. We'll just do a few and see if we need to continue or see if we have enough there. Then for 12, the multiples of 12 would be 12 times 1 is 12, 12 times 2 is 24, 12 times 3 is 36, 12 times 4 is 48. And then for 18, multiples would be 18, and then 18 times 2 is 36, and 18 times 3 is, let's see, what is that? That is 54. And then 18 times 4, and on, okay? So, we can see from here that we found the least common multiple, in other words, the smallest that's a multiple of each, and that's 36, because each of them have multiples of 36. So, that's the list method for finding the multiples. We can also find multiples by using the factor tree. So let's use a factor tree, and let's keep that same example. So we have 9, 12, and 18 again. And let's do factor trees on all of them. So 9 can be broken down into 3 times 3. 12 can be broken down into 3 times 4. And then 4 can be broken down into 2 times 2. On 18, that can be broken down into 2 times 9, and then 9 into 3 times 3. Okay, now if we were doing GCF, this is what we would have done. With GCF, we look for what they all have in common. And the only thing that all of these have in common is 3. Okay, so the GCF would be 3. But LCM is a little bit different. We're going to take every single factor and we're going to take the highest power of that factor. Okay, so for instance, here we have 3 squared. Here we have 2 squared times 3, and here we have 2 times 3 squared. So we're going to use every factor and take the highest power of that factor. So if we look at this, there's a 2 here, and then there's a 2 squared here. So we're going to take the highest power, so we'll take the 2 squared. So our LCM will start off with that. And then we look at the 3's. We have a 3 squared here, a 3 to the first power, and a 3 squared there. So the highest power of 3 that we have is 3 squared. So we're going to write that. And then obviously 2 squared is 4, and 3 squared is 9, and that equals 36. So the LCM once again is 36. So we found out, on the previous page that by the list method that the LCM was 36. And then the factor tree method will also give us the same answer. So it's a matter of preference, and it's also a matter of how big are the numbers. You wouldn't want to be listing the multiples if these were large numbers. That wouldn't be very much fun. So factor tree method, just like with GCF, factor tree method is great for larger numbers. List method might be fine for smaller numbers. Okay, so then we get to the question again, why would I use this? Why do I need to know what the least common multiple would be? And we use least common multiple when we are trying to add fractions, for instance. Okay, if I wanted to find out what 10/13 plus 3/5 was, I would need to figure out what the least common multiple of 5 and 13 is in order to figure out a common denominator. So you're trying to find the least common denominator for 5 and 13. So I could, if I didn't know what it was, what I could do is I could do factor trees. And with 5 and 13, a factor tree would be pretty easy, right? Because 5, it's just 5, right? And 13, same thing, 13's prime, so it would be 13. So then I would do 5 times 13 and then find out that that would be 65. Okay? But, with other numbers, this isn't a wonderful example. With other fractions, you might then need to actually do a factor tree. But, I would go ahead and go, okay, 65 and 65. And then, how many times does 13 go into 65? And I would say, okay, it goes into 65 5 times. So 5 times 5 times 10 is 50. And then 5 goes into 65 13 times. So 3 times 13 would be 39. And then add those together and get 89 65ths. So that's when you would use least common multiple, is to try to figure out what the least common denominator is when adding fractions.